What's up everyone? Welcome back to my channel. Today we're going to do a geometric or trigonometric problem, which probably you have already seen my first video of finding the value of the trig functions of 15 degrees and 75 degrees, or for people who love in radians, it will be pi over 12 or 5 pi over 12. But today we're going to use a slightly different method of what we have done in my first video and trying to find out the value of sine, cosine, and tangent of, as well as cotangent of 15 degrees or 75 degrees, because again, sine and cosine are actually interchangeable, as well as tangent and cotangent. So here we go. So on the board we see the right triangle, of course, is just a specific one. The special case 30, 60, and 90 degrees. And of course this should be already memorized for most of you who have already taken the geometry class. And of course the ratio will be just 1 to square root of 3 to 2. And again, when we talk about the ratios, it's going opposed to the angle that we're corresponding to. So what should we do this time? Well, it is actually a method that I believe that actually may have been done to by other mathematicians or professors on YouTube, but not sure. I didn't really check every single channel. But if it's just the same idea, please don't scold me, because there are just too many channels to actually on YouTube that are actually doing math. So the method that we're going to do is we're going to consider a circle where the center is at this point. Okay, here is the center of the circle, and the radius that we're taking is actually the longest length here, which is from here to this point up here, meaning that the vertex on the top right is actually lying on the circle. So just pretend that the circle looks like this. Okay, and then it will actually start going down, curving back in, something like this. Okay, let's say this is a circle. Good. Then what should we do next? Since this red arc here is actually part of the circle, let's try to extend this horizontal line on the bottom. And to do that, I'll use a different color. Okay, if we extend this horizontal line, as we see that this horizontal line will eventually reach the circle, it means that from this mark here, which is the center of the circle, to this point here on the circle, should have the length equal to the radius of the circle, which is just 2. Okay, we'll actually label it here, meaning that the total length here is equal to 2. So it means that this green part that we just extend will have the length equal to the total length 2 minus the part that we started off with, which is radical 3. Good. Then with this new point here, we can just try to draw a straight line. And keep in mind, this red part is not a straight line, is part of the circle, is an arc. So if we try to draw a straight line, we'll actually get something like this. And of course, since the green part on the bottom is an extension of the bottom line, the angle down here is also a right angle, because these two are supplementary. So if we add up these two, this should end up with a straight angle, which is 180 degrees, or pi pi for people who love using radians. And since the left part is just half of it, it's pi over 2, the other part has to be pi over 2 as well. Good. Now, what does that do? Consider that this total length down here is equal to 2, which is equal to the hypotenuse up here that's given. And again, that's because these two are actually the radii of the circle. It means that now this biggest triangle that we have is in fact an isosceles triangle by definition, because we have two sides of the triangle having the same length. And since it is an isosceles triangle, the corresponding angles will also be equal to each other or congruent to each other. In other words, this angle here is going to be equal to this angle. And how do we find out the measure of those angles? Because we know that this is on a Euclidean plane. The sum of the angles of a triangle is always equal to 180 degrees, or pi. And then we know the leftover part, which is 30 degrees, or pi over 6. And we claim that these two angles are the same. So we just need, in order to add these two up, if we call this each angle theta, we have theta plus theta is equal to pi minus pi over 6, which is equal to 5 pi over 6. Okay, and we just have 2 theta on the other side, meaning that each angle is just equal to 5 pi over 12 as we divide 2 on both sides. And again, that's just equal to 75 degrees. So now we have the 75 degrees that we want. And of course, this small part here will be 75 minus 60, which is 15 degrees. Or equivalently, pi over 12 radians. Then now we have the right triangle that we need, that is labeling the length of the two legs. 1, 2 minus radical 3, with the angle here 75 degrees, or 5 pi over 12. And here the sharp one will be pi over 12, or 15 degrees. So the only side that we don't have is the hypotenuse of this right triangle. And of course, we can just use the Pythagorean theorem to help us finding out the length of the hypotenuse, which is the square root. And again, because we're talking about a triangle on Euclidean geometry plane, and we're just thinking as high school geometry, so the length has to be non-negative, or in fact it is positive. So we will have the positive square root of the square of the first leg, which is 1 square, plus the square of the second leg, which is 2 minus radical 3 quantity squared. And as we try to simplify it, we'll get the square root of 1 minus 2 squared is 4. 1 plus 2 squared is 4, minus 2 times the first term times the second term, which is 4 square root of 3. And then plus the square of the second term, which is just 3. And this gives us 8 minus 4 radical 3 under the radical. And if we factor out if we take out the 4, we just get 2 times the square root of 2 minus radical 3. And again, we can actually try to simplify this into 2 times multiply these by 2, And of course, we need to divide the same thing here. And then complete the square for the numerator. We will get radical 3 minus 1 on squared, and then cancel with the square roots. So we will have the following, which is square root of 2 canceled out with the 2 here. So we have radical 6 minus radical 2. For this leg here, radical 6 minus radical 2. And last but not least, we just need to use the definitions of sine, cosine, and tangent. So of course we can also include cotangents to get the result. Sine of pi over 12. And then cosine of pi over 12, which is equivalent to cosine and sine of 5 pi over 12 respectively, as well as tangent of pi over 12 and cotangent of pi over 12, which is same as tangent of 5 pi over 12. And again, by definition, sine is equal to opposite over hypotenuse. So we have 2 over 3, not 2 over 3, 2 minus radical 3 over radical 6 minus radical 2, and we can just try to simplify it to get the result. And here we will have 1 minus radical 6 1 over radical 6 minus radical 2. And last but not least, tangents will be opposite over adjacent to give us 2 minus radical 3. And tangents of the other angle will just be the reciprocal of it. And that's it. And of course, if we simplify, we should be able to get the results that we actually have in the most common way. All right. Hopefully you enjoyed this video, and if you do, please don't forget to like, and you can subscribe to my channel to find more of my other videos. And if you can turn on the notification, you'll be able to catch up with all my new videos without missing any, hopefully. I'll see you guys in the next video.